Hello, everyone. I'm Megan Matheson. I'm the co-lead of the Canadian Marine Shipping Risk Forum and also the Director of Strategy and Engagement for Clare Seas. I'd like to note that the session will be recorded and then we will post that on our website along with the presentation slides after this session. And everyone who's registered will receive a notice when the recording is available. Just going to admit a few more people. So before we get started today, I'd like to take a moment to acknowledge that I'm joining from the traditional ancestral lands of the Musqueam, Squamish, and Tsleil-Waututh nations and express my gratitude for their stewardship of the lands and waters in this area since time immemorial. For a few brief introductions, the Canadian Marine Shipping Risk Forum is a community of practice that's hosted by MEOPAR, the Marine Environmental Observation Prediction and Response Network, and also Clare Seas. The community of practice is open to all who are interested in the work of understanding and mitigating shipping risk. Thank you so much for joining us in this session of our Beyond the Horizon webinar series, focused on technology and its role in mitigating shipping risks. If you've missed any of the previous sessions, I'll share the links in the chat shortly and you can take a look at your leisure. So this webinar series is investigating different ways technology is being applied to understand the marine environment with a particular focus on the activity and impacts of vessels that are operating beyond line of sight and also within line of sight. So we've looked at vessels not using automatic identification system transponders and vessels that have communicating in different ways. Looking at thermal cameras as one example to track whales and avoid collisions. And today we're getting into pilotage and how technology can change the way that pilotage has been occurring. So looking specifically at Finland. And just a couple of housekeeping notes. If you can please remain muted during the presentation. We will have lots of time for questions afterwards, so please raise your hand and unmute to ask questions after, or if you'd rather, you can type your questions into the Q&A and I'll read it out so that our presenter can answer. So over to today's presentation, we are going to hear from Osiris Valdez Banda, an assistant professor at Aalto University in the Marine and Arctic Technology area. And Osiris is the leading professor of the research group on safe and efficient marine and ship systems. His research focuses on the analysis of maritime risks and safety systems engineering with applications in the context of smart shipping and winter navigation. His work also focuses on the development of methods, processes, and tools for modeling and analyzing the risks, safety, and resilience of ship and marine systems to support the design of autonomous technologies, smart shipping services such as remote pilotage operations, and tools for the management of maritime traffic operations, particularly in the navigation of sea ice-covered areas. So I'm going to hand it over to Osiris to start his presentation.
Okay, thank you very much for this introduction. It's a pleasure to be here. Today I have basically the duty of introducing in very short time all the hard work we have done for this risk analysis or risk-based analysis and decide for remote pilotage operations. So an initiative we have been working for several years here in Finland with the targets for allocating this potential service available in the near future. This is something that is still continue ongoing, but this is not an initiative that pop-ups like a new aspect related to that. So it comes along the hard work, at least I have been kind of like fortunate to follow from previous years. Since 2016, when I started to join research related to everything what is in the context of smart shipping, maritime autonomous surface ships, and maritime autonomous technologies in general, which has been something quite important for the maritime cluster in Finland and how to develop this kind of like a new concepts of ships or even new smart shipping concepts for providing smart services in different sea areas. So this remote pilot is actually, let's say that the root started with the AVA project, this autonomous waterborne applications initiative that we start. Basically, the entire Finnish maritime cluster was involved in this initial project. It was a very large project with a lot of funding to start to look into what alternatives do we have if we start to think about potential solutions linked to autonomous maritime technologies and the type of services that we can define around that and concepts for that. Then it continued during the design for value which focus more into this kind of like a key development areas for the maritime cluster in Finland, and in connection to everything what is around the context of maritime autonomous surface ships, or things related with establishing new technologies for enhanced communication on board vessels. Some kind of like an introduction of the role of remote assisted, remote controlled, and autonomous solutions for ships. So we start to evaluate what are the potential kind of like optimization we can obtain from this type of services, from this type of technologies, together with the companies who actually were developing those companies, together with authorities who were basically monitoring the whole development to guide this type of process for aiming for this kind of like advanced technologies to be utilized in the maritime cluster. And then, of course, as part of a university and research institute, we focus a lot on the aspects related to how to ensure safety, how to analyze risks, how to determine specific controls to ensure that if we develop these technologies, a new concept will be basically applied in the future, how to guarantee that these are safe by design. That was kind of like important. Then we start to narrow down after design for value to start having a specific kind of like cases or applications that we want to basically develop. I'm not going to talk about all of this, but there was some autonomous ferries for urban waterways operation was one of the projects that we have. We start to talk more about autonomous ships concepts. So decreasing the amount of people on board vessels, relocating the bridge, or even thinking about having a bridge zero concept on board the vessel. This is something that we elaborate together with some kind of like industrial partners and other research institutes. But then what I'm coming to talk today is about this C4Value, the project in the middle that we started in 2020, which was focused basically on remote pilotation and intelligent fairway. So it has been basically started from these two projects I mentioned that before, and then was continued during this project that actually closed last year, and now there are some sequels there for continue the research on that. So this is basically the consortium, a lot of industrial partners related to the development of technologies, research partners also involved there, universities and some research institutes. The main funding partner for this project was Business Finland, and basically the official name of the program was C4Value Fairway. So how to have remote pilotation and intelligent fairway was the main concept to be developed there. So quickly as a background, because I think that's something that everybody knows, what is ship pilotage. So we know that when the ship arrives into certain areas, either congested or shallow areas, we need to have some experienced navigators who can actually take control and basically take the ship into the final destination in a safe manner. So these people are quite good experts on the local waters. They go basically on board the vessel as a pilot, and then basically provide the guidance and the support to have this final destination on reaching the final destination of the ship. What is known also from the statistics is that when we have the pilot on board, we have a lower number of accidents, at least on the records. So if it's a significant comparison if we think about the accidents of those vessels when we don't have the pilot. So pilot is kind of like a critical task for the final last mile of navigation, we can say. So the challenge for pilotage, well, was a complex and critical operation, as is of course in the kind of like a congested areas. For example, here in Finland, the grounding is a higher risk when we are talking about piloting or having activities during summertime, and then the increase goes balance more to the collision side when we have actually ice in our seawater. So that's kind of like what we see in the terms of this type of accidents that we have during different seasons. So it's also risky for pilots, as also accidents occur when pilots get on or off the ship. So different kind of accidents have been reported worldwide. And also accidents have been reported in this area related to extreme weather conditions and the role and tasks related to the pilot. So sending the pilot there, it will that this is already like taking and considering some risk to be embedded in this provision of this service. The pilot service invests a lot of resources in providing this service. So that's also something that is quite important. So all this experience and all these kind of resources invested for providing pilot is something that is significant for balancing there for those vessels who actually require the service. So what kind of like a potential or what kind of like a new solution or alternative we have related to the provision of pilot, what is basically this remote pilotage concept that is focused that instead of boarding the ship by the pilot in a remote pilotage, the remote pilotage can support the ship crew from this kind of like a shore control center and provide guidance. This is very important to mention when people listens for this time or for first time to this remote pilotage. Is remote assisted pilotage. Is not remote controlled, at least not for the case in Finland, which is kind of like a quite important to notice that the assistant is given from a remote location, but there is not the pilotage is not taking any control of the vessel from a remote control center, for example. In Finland, we have this Finnish piloted ad that is quite important to know how to run or from the legal side to establish how the pilotage is basically done, and it was amended in 2019 and again in 2023 to allow remote piloted services in Finland. It's also quite important to notice that for this kind of like a amendment on 2023, some new risk analysis were determined for critical fairways, particularly for those fairways where remote pilotage seems to be an option, but mainly was the whole analysis of the risk related to the most critical fairways in Finnish sea water. So that's something that we did together with some other authorities. There are, of course, for remote pilotage, there are challenges that come with just the task of trying to elaborate the service and provide the service. So we need to have more embedded software and more advanced technology in place. So for allowing this kind of like a remote assisted pilotage operation. And this also creates the issue that with the inclusion or addition of more software and more technologies, we had more like a systems interaction, which kind of like lead to errors on software and design errors. So in this case, I think then the safety becomes a priority on designing a system that has to be safe by design. So for some of the tasks that will be developed by the pilot in a remote location, certain elements of technology need to be assured all the time, because the responsibility has to be properly delegated to this human-machine teaming interaction, I will say so. As I say, higher numbers of interaction between components, which can also result to unsafe interactions. So that's very important to really understand all this coordination and interlinks about different elements to find ways for assuring a good allocation and linking of these whole components for remote pilotage by requirement. It says here that the piloted ASH specifies that a comprehensive risk management study is necessary to enable remote piloted service in Finland. And this kind of like a risk management study refers to analysis of risks on the fairways where this can be provided, but also analyzing the risks on the initial aspects to design remote pilotage as a service. And then, of course, this could continue when the service will be basically developed or implemented. So then, how we did it in this C4 Value project? We use basically the structure of the formal safety assessment. I think perhaps many of you are already familiar with this process, which starts with the system description, continue with the risk analysis, elaboration of risk control options, assessing the cost and the benefit obtaining from the risk control options that you implement, and then, of course, the final developing of a structure of a safety management or risk management strategy is documented and provided for basically the responsibles and the final end users of this remote pilotage. So, however, when running this formal safety assessment, especially for advanced systems like remote pilotage, we start to figure out that there are some limitations for that, so that we need to do more than just follow the process of the TPA. We need to develop some specific elements. So particularly in this develop of the description of the concept of operations to understand what are the system components and how they will function. That was something that we developed together with the pilots in a very extensive task that I will show quite quickly. We conduct the risk management of remote pilotage as such on the service, on what are the components and the interactions and the process for remote pilotage that we analyze. And then we also kind of like made this kind of like integration of different suitable methods for risk analysis, for modeling this, for describing the models, or for representing the models, to discuss the models and represent how the operations will be executed. That's something that we also need to elaborate a little bit more on that. So particularly, I will say that for the remote pilotage system description and the elaboration of the initial CONOPS, we need to do a lot of tasks, a lot of work for concluding this first step. And actually, the challenge starts already by noticing that, for example, in the FSA, the step 1 or 0, I call it sometimes. So the goal is called in system definition. There are no alternatives offered or explicitly offered for making this type of description, especially when it's something that is entirely new. So we have some kind of like issues on that, and this is also referred to other studies when the FSA has been criticized of being a little bit ambiguous to have this kind of like elaboration of the system description. So then that's why we started to look into model-based systems engineering as a solution to reduce this ambiguity, and then utilizing models to minimize text, and then to have more like a model representation that can be discussed with different stakeholders related to remote pilotage, or people who are in the interest on developing this risk management strategy for us. So for us, we have the challenge to think about that. Okay, the model-based engineering is a solution, but what kind of tool we can utilize for that? So we need to start to look for those methods, and the suitability of those methods then will depend on different kind of like elements. Of course, the first is the system scope. What is the system to be considered, and how complex it will be? And then the purpose of the modeling, why we are modeling this, for what purpose the model will be used. In our case, was for elaborating this kind of like a risk analysis and the setting the basis for the initial risk management strategy. And then, of course, this is something that cannot be just embedded into the people who can actually research risks related to remote pilotage, but actually I will say that everybody on board on current pilotage was also considered on the discussions for elaborating this type of description, and then looking for the most suitable alternative for modeling the system. So for that, we call it a decision-making framework for selecting this kind of like a suitable modeling language in this model-based engineering. So end users in remote pilotage were entirely taking on board on having this discussion, trying to test different alternatives, following this framework to try to see what is the most suitable option for that. Different comparisons were developed also for the existing alternatives. And depending on the usability and an understanding of these end users, we started to look in which seems to be the most suitable alternative for us. The tool that actually we decided at the end, it was this SysML, this system modeling language, because that offers a kind of like a more adequate capability, and also kind of like allowed to have this representation in a way that, for example, in our case, the pilots and the people related with the current pilotage can actually see the modifications that may come from migrating from common pilotage to this remote pilotage aspects and the element that has to be done there. So together with them and together with different end users, not only pilots, but also the different authorities, different technology developers, we start to look and we start to make this kind of like a description of diagrams related to remote pilotage, where we have all the descriptions related to the components on remote pilotage. You can see some of the main labels here: shore control center components, sheet components, and fairway components, and others. I will say that also from this remote pilotage concept, the main idea or the main interest from pilotage itself was to basically try to transform more the fairway than asking for added technology on board the vessel, because we know it's complicated, we know it's expensive, and we know it's problematic. So I think the main focus was to see on how to develop our fairways in a more intelligent manner. So once we have this kind of like a different kind of diagram for different components, this kind of tool, this SysML, was also very good to start to describe how the process of remote pilotage will run. So as you can see it here, I'm not going to read it, but basically There is a whole process where it involves the tasks related to the remote pilot, the tasks related to the master, the agent, and also in the cases where the talks will be needed. So what is going to be the role and how the process will go. The nice thing about this kind of tools is that if you need to include specifications related to the tasks that you can see here, by clicking on these elements, you can see what is actually supposed to be elaborated on each task of the process. So it was a very kind of like a intuitive way for to discuss and further elaborate how the process will be developed and what are the needed aspects that has to be available for providing this service in a safe manner. And of course, the connection with the different components that we have identified there. Once we have this kind of like a very detailed descriptions, and I can basically tell you that this took in a project that was almost 3 years. I think just making the system description and the description of the process took almost half of the time available in the project. It was quite detailed system description, but I think it was kind of like important and valuable to have it in that way, because then when we start to jump into the risk management part, we start to look on, okay, how we can identify hazards and how we can analyze those hazards and start to have this kind of like a hazard and risk analysis implemented to remote pilotage. So for that, we also use kind of like advanced hazard analysis method, which is basically call it a CPA, system generated process of analysis. It's a process basically utilized for complex socio-technical systems, which basically considers safety consider safety as a dynamic control problem rather than just a failure prevention problem. So how to include and install controls to rule the behavior of your system is the main aspects of this type of like a hazard analysis method. Then with the system descriptions that we have and the connections among critical stakeholders, critical components, critical tasks that we need to develop for each of the tasks that we have on in each of the stakeholders that we can list here, we start to look into the analysis of these interactions. So where remote pilotage is controlled with the role of the master, with the remote pilot displayed, navigational deck officers, the connection with the other traffic, the connection with existing vessel traffic services, how this can be modified also for the current role of BTS. That's something that was basically discussed and analyzed into a specific kind of like a control actions to be included there. And then, of course, things related to the control station and display, some of the things that we need for remote pilotage were also tested, related also to technologies embedded for having kind of like a very accurate description of the things needed for remote pilotage and the final outputs of this type of system description. I just need to say that the figure I'm showing here is a very, it's a kind of like a synthesis or a very kind of like a minor representation of a whole model that we have somewhere else. But if I show you the whole model, it's very problematic to have some kind of like this proper displays of that. But I will show you at the end where you can find all the details that you can see here, including the whole description of the model. So then when we start to look the hazard analysis, at least for this kind of like initial risk analysis, so for the first time that we are making the risk analysis for remote pilotage, we just consider this type of losses, and you can see it here. When it focuses on injury to people, damage, loss of or damage to ship and cargo, loss of or damage to external objects, loss of the mission, affectations to the environment, and of course, things related to customer satisfaction related to the provision of the service. 5 system level hazards were considered for this analysis. Then the focus on the pilotage operation, how basically the ship violate the minimum separation standards, which is quite critical aspect in maritime navigation here in Finland. The hazard number 2, that the ship doesn't maintain a safe under-keel clearance. The ship leaves the designated route, lack of communication, initiation between the remote pilotage stakeholders during the execution of the service, and the lack of information sharing between remote pilotage stakeholders during the remote pilotage service. That's something that we basically determine as system level hazard, and we link it to the losses that you can see on the top. Once we start to determine this hazard, we start to identify what we call unsafe control actions. So how these basically unsafe control actions can activate or can lead to the hazard, then actually going then to the loss or to having an accident. So there is around 150 unsafe control actions that we identified. You can see some of them as an example there. So remote pilotage does not initiate communication with master prior to the pilotage. Going to things related to navigational crew provides a rudder angle too late during pilotage operation, going more into the specific issues executing to the operation that can actually endanger the execution of remote pilotage. So it's a very long list. It's more than, well, basically it's like a, I don't remember the exact number, but more than 150 unsafe control actions that we identified there. Then together and combining these unsafe control actions and the hazards and losses, we create more than 800 unsafe scenarios that were identified. And we start to basically categorize or group those into 3 major categories and more than 15 subcategories. The category number 1 was the issues related to hardware and software, where the things involved, all the things mainly critical for remote pilotage. The issues related to human factors, and then the issues related to incomplete, incorrect, unclear, or lack of data. Data transmission was also quite important, or is very important also for the provision of this kind of like a remote pilotage. So once we have this kind of like a categories and we start to list or link it to the unsafe control actions, then we start to basically identify what are the potential causes of these control actions to kind of like redefine how the control should be installed into this remote pilotage. So you can see some of the causal scenarios in the lower part, but there's a lot of the description related to that and many kind of like aspects on this very long process that we use for the hazard analysis. I'm showing you here some examples. Well, the database recorded for all the issues and the interconnection among these kind of like unsafe scenarios and the losses, the hazards, and the safe control actions is everything is interlinked on a database or in a model that we also create. So, but going into a specific things related to what was analyzed there, we analyzed safety or risk related issues linked to the equipment. You can see some of the you can see actually the equipment that was considered for the analysis on this part. So we also have this kind of like a analysis of safety and security issues related to information exchange, as I say, data exchange, and the transfer and the transfer of data and the communication works are very important to also to analyze. These are the components or the kind of like the main aspect that we evaluate on this safety and security related to the information exchange. Then human factors that we at least start to analyze these elements or the human element for remote pilotage. I don't think that is basically concluded, but I think what we have is something quite good as a basis to continue the development on the new initiatives that we are working on that. But just for example, as an example for you, when we start to look into safety-related human factors and the main factors or issues that are listed there on this square, we start to look into this lack of skills and competence. So everything related to skills related to remote pilotage, what are the navigational suggestions, the pilotage planning, the establishing connection and sending information, the suggesting emergency procedures, communication skills, situational awareness, and handling of the new equipment or the current equipment is also was analyzed for that. Skills related to master and navigation crew, vessel navigation, communication skills, executing emergency procedures, etc. So everything what is relevant for the competence and knowledge of pilotage that we believe at this initial state that is critical for remote pilotage was there included. And then we start to link it with the kind of like a control actions that we start to determine, or these risk control measures that we start to list there. So how to properly make the selection of the ship and fairway. Simulation practices for remote pilotage was an initiative basically included there. The demands for the experience and the skills needed for the pilot given the remote pilotage. The backup or duplication, or basically the kind of like a way for assuring the communication can be guaranteed at all time, especially with the new systems and new components added for remote pilotage. We also discussed about the aspect needed for having the certification of remote pilotage and its validity. the training needed for the pilots, what kind of emergency procedures can be run in the case of an issue during remote pilotage, and then things related to new systems like how to increase the situational awareness and how to make a proper utilization of sensors, camera, and stations, and everything related to the technology embedded on these smart fairways and things related to the technological aspect needed for remote pilotage. This is something that we also include there. Then we start to basically create our risk matrix and create a kind of like a description and allocation on the risk level for each category that we designate there. As you can see, in low risk level, there are 18 categories. 9 categories are related to the medium risk level, and then 22 categories are basically allocated for high risk level. These risk categories basically are based on the implementation of risk control measures during remote pilotage, and the successful of the implementation will be tested against the kind of like a new control action that will execute to test how efficient and how well we can actually decrease the risk identified on this matrix. So once we start to identify these categories and start to identify potential risk control options, for the determined risk control options, we did this kind of like a risk, this cost benefit analysis on the risk control measure that we basically allocate there. For everything what we allocate there, that basically we see that the expectation from the effectiveness of the reduction of risk from the risk control measure that we utilize, 169 seems to be represented or understood by the end users as having potential to be very high effective for reducing the risk. And some of them, only 2 of them were in the rank of a very low effectiveness expectation from the risk control measures. Then when it comes to the costs, we also try to balance and make a preliminary analysis on how costly will be the implementation of this category, these categories and the risk control measures embedded into that. So some of them actually were mentioned as not as having any expectation of any significant cost or not cost at all. Low cost around 70, 51 with the average cost, high cost 54. And of course, very high cost, it was only determined to be 2 categories that were basically allocated on that. Then of course, once you have this risk control measures and the actions, you need to know, well, for us, it was very interesting to know which kind of combination seems to be the most adequate or the most promising to reduce the risk by having also a balancing aspect related to the resources that you need to invest, particularly the financial aspects. So we create a model on this influence diagram for the remote, we call it influence diagram of remote pilotage operation, with basically the idea there is to test different risk control measures against the effectiveness expected from that, plus also the cost expected from that, and then try to balance which needs to be the most kind of like a promising combination of that. The diagram is focused on critical risk nodes and can estimate the total expected benefit by calculating the benefit due to risk reduction and the cost of implementation. And what I can say quickly in general matters about this, or in general terms about this model, is that the important measures in the selected risk control options that seems to be more adequate or seems to have the highest potential to reduce risk by also having a less impact from the use of resources, where the redundancy of data collection and transmission units, also a standardization of language utilized for assisting or providing the remote pilotage, and some specific requirements such as certification and the minimum crew size required for remote pilotage that has to be demanded, where some of the measures that seems to be like the most promising in terms of a combination and in terms of the capability for reduce the risk. So we believe that with this model, with this analysis, we provide this kind of like a basis for the risk and safety management strategy of remote pilotage. As I said, this is the basis, and we still need to elaborate more aspects in relation to the future aspects on developing this service in the upcoming times. So then that's something that is still not yet and not soon to be concluded, but I think we have a very good basis to start to developing what are these aspects? So when it comes to determining some kind of like specific recommendations and allocation of critical aspects from this analysis, what we provide now is that we have more than 50 loss causal scenarios identified for remote pilotage operations. And when testing again some particular ways for controlling the risks and how is the benefit when it comes to evaluating the effectiveness and the cost. The risk management strategy defined with this kind of like risk control actions should be used, well, is going to be used. And I'm talking about the past, but this is something that's already happening. It's going to be used as the foundation for the definition of a structured management system that can continue the design and the future operation of remote pilotage in Finland. This is very important because I think our analysis make a lot of distinctions and a lot of focus on the context where remote pilotage is going to be developed or executed in the Finnish case. So basically here in Finland, as I say, aligned to the task that you can see here on this focus on the risk analysis of remote pilotage, as I mentioned at the beginning. We have done some critical analysis of demands and risks embedded into the navigation of critical fairways, so the most important fairways for Finland. This is something that we have done in a parallel project without having too much the focus on remote pilotage, but of course the main outcomes of this analysis will rule or will guide or will determine the specific requirements that need to be embedded, or determine already specific requirements that need to be embedded on this remote pilotage operation. The output of this work supports the definition of safety requirements related to remote pilotage. Preliminary after level requirements exist already in the Pilotage Act, but of course, when it comes to specification related to remote pilotage, I think now with the whole information that we allocate here, it's quite constructed and it provides a lot of kind of like a rich level of information to continue to determine all potential final requirement that may come by regulation or by the operational side when the process or the service is basically provided. We basically had the demonstration of remote pilotage in 2022. And of course, it was very good for us also to test or to validate, well, not to validate, but to test some of the results and also to influence some of the aspects needed for determining a successful demonstration case in 2022. So some of the information provided from this risk analysis were already allocated or embedded in the settle of the needed basically aspects for this demonstration, either on the fairways or either in this remote pilot center, and also for the people on board when they knew that they're going to be remote piloted. So kind of like a different aspects were available there for this task. For the next kind of interactions on the continuation of this work, the scope of the analysis should be expanded to a higher level. So as I say, we have a lot of focus on the pilots as such, but I think we already started some discussions with the Finnish Transport and Communications Agency, Finnish Transport Agency related to safety aspects. This is something that we have discussed, but I think in the next steps, we need to have more like or we need to expand this analysis to see and determine what kind of responsibilities and aspects will be also needed from the side of the other involvement of authorities. I can say about the continuation that at this moment, once we close the project, we have continued some of the analysis, and now we have some kind of like initiative already submitted to the European Commission to continue the work in Finland, and also now in collaboration with other European countries that were also interested on the concept of remote pilotage. So I think by July, we will get to know the comments or the opinion from the European Commission to know if we basically engage into this new project alternative to continue the work in Finland, but then to extend it to initiatives carry on, for example, in other countries inside here in Europe. So as I say, all this information may sound quite general. So if you have questions, please feel free to ask, and I hope I can answer to this question. If you want to know more details about all the specific steps that we did on this work, you can check this doctoral thesis by one of my recent doctoral students graduated, Sunil Basnet. He defends his doctoral thesis actually 4 months ago. when it's everything related to the managing of risk of maritime remote pilotage, with the use of this formal safety assessment is represented there. So the link is there and it's available for everybody who wants to check it. So all details on the work carried on there is basically available there. And then just to conclude, this is basically the whole team around this task. So I am the professor responsible, but mainly Sunil, my doctoral student, together with my postdoc Ahmad and my other doctoral students, Miriam and Jane and Evelina. Also, they help us on developing the whole task. I briefly try to introduce and inform to you about this remote pilotage. So I think I will close here, and I'm happy to take any questions.
Thank you so much. That was a great overview of the process involved. I'm sure there'll be lots of questions, but I wanted to start with, where did the impetus for this risk assessment come from? Like, who identified the need for this project?
Well, the main interest comes from the pilotage, or the pilots as such. So here in Finland is Finn Pilots. And of course, is embedded into the actualization of this Pilotage Act. We require the risk assessment by rule. And this is determined by for example, the Finnish Transport Agency and the Finnish Transport and Communication Agency, which are responsible for safety aspects related to maritime safety in Finland. So this is kind of like it's a demand coming from that side. And when we were thinking about this remote pilotage, this risk-based decisions has to be properly done to fulfill the demands coming from the authorities.
And that was coming out of the modifications to the Pilotage Act that happened in 2019 and 2023.
Yes.
Right. Do we have any questions from the audience? Feel free to raise your hand and unmute and ask directly, or you can use the chat function to type a question if you prefer to ask it in that way. I was wondering if you could talk a little bit more about, just looking through my notes, that you said that you were considering safety as a dynamic control problem rather than a failure prevention problem. Can you talk a little bit more about the distinction there and what that looks like when you're thinking about pilotage and remote pilotage?
Yes, I think the dynamic aspect comes from something that we carry on now with this initial risk analysis. And I think that what we are talking all the time here on having this kind of like some people call it dynamic, some people call it real-time risk analysis when the operation should be executed. And that's basically something that we can determine by having the data obtained from the pilot, from the operation as such, and running specific models to test some kind of like a risk index on a specific determination of the task executed at that time. That, for example, on this parallel exercise that we did for determining risks on a specific critical fairways, something that we anticipate based on historical data, we have similar ships visiting the time, is that in having a kind of like replication of the potential operation according to the conditions that we have in the fairway and the characteristics of the vessel which is coming to navigate on that area, to determine in advance if the vessel will require the common pilotage or it's also it can have the opportunity to be having this granted service as a remote pilotage. But this is basically done with a kind of like a type of simulation before the ship can enter the area, to know in advance, according to the historical data and the data coming from the context where, over the context, the whole context of the fairway, to determine what is going to be the conditions needed for guiding this ship to the final destination, and in relation to what is going to be the role of pilotage there. So we are developing different type of tools for that. Some of the models that I show here actually are being developed on a specific, more like algorithms that can be run as a background for this monitoring short and getting to know before in advance what is the expectation and the estimated route and things like that, so that you can determine safety margins and safety aspects that has to be fulfilled, and then determine what are the the kind of support needed for that vessel when it comes to a specific fairway, or when it comes to this kind of like a requisition or request, sorry, of this remote pilotage or common pilotage. Yeah.
Right. So we have a question from Paul Palmeras, Executive Director of Clear Seas.
Yep.
Did you create a baseline risk model of the current state with physical pilot transfer for comparison to the remote shore-based pilot?
Yeah, let me read it again. Did you create the baseline risk model to the current state with the physical pilot transfer for comparison? Yes, basically, many of the things considered here on the initial risk analysis that we have were basically started by including the analysis of current pilotage. And then basically from there, we determine then the elements needed for remote pilotage and what kind of new additions will be included into complement our risk analysis. And as I say before, I cannot even say that the initial risk analysis is already complete. This is something that still is ongoing. And there are certain elements that still need to be determined to continue for the remote pilotage risk analysis to start to say that in an initial phase, it will be concluded. That's why we have this new initiative on trying to close that gap for the initial risk analysis and start to determine how these risk control options that we start to foresee going to be implemented in the real execution of the pilot, yes, of the remote pilot, sorry.
Okay, we'll go to Cedric Baumel next. Has his hand up. Go ahead, Cedric.
Yeah, good afternoon all, and thank you very much for the presentation. I mean, very, very interesting. Just a quick comment regarding the risk analysis, and just to be sure that the way that you build the entire project, it's fantastic. I mean, I think it's targeting a very good point. Although that being said, did you include it in by factoring the risk? Let's say the competency of the crew. So what I mean about that is, let's say that you get a ship which is going, every month, in a monthly basis in the same area. I mean, the crew on board may have more familiarity of the area. Is this thing have been included in your risk analysis or as a factor?
We consider mainly as an assumption, because it's true what you say. So the people who are coming to navigate on this area, some of them may have already an expertise, which allow you to also back up the idea that remote pilotage is more suitable for a specific case of specific ship that is more familiar with the area. So this is something that it has to be tested. We start the analysis of competence related to remote pilotage, but also we consider the issue that you mentioned related to ship crew, but that's something we have not got quite deep. And I think that's a very good point, because if you start to consider specific cases, then it basically means that our potential risk scenarios will be changing according to the type of risk and crew and competence that we have on board. Yeah, I think that's very interesting, but I think that's opening kind of like a quite broad spectrum of analysis that we need to discuss also with the pilots here and also with the authorities, because this is very important, but also very interesting question, but at the same time quite challenging. But yeah, we try to include some assumptions about that, but I cannot claim that everything is considered for that aspect. Yeah.
Yeah, it gets
Thank
quite
you very much.
Yeah.
To include lots of different things. So Mike Cujo has a somewhat related question, asking about, since different ports have unique features, environmental features among others, how scalable do you think this approach would be?
Yeah, that's actually a very good question, because this is something we have discussed with the other potential partners outside Finland, especially some, for example, some Denmark and Spain. They are thinking of, or even Portugal. We are discussing about this issue, and we talk about this, that what it means remote pilotage for Finland or for a specific fairway, it may be something quite different depending on changing the context. So if the environmental conditions, the port infra, the description of the fairway, the demands of the fairway, the challenge of the fairway may require to have this kind of like a special conditions for particular fairway. But that's why I say that's why we look into this parallel analysis to really understand what are the main risks of the main critical fairways in Finland, and try to see on this risk and the needed requirements to mitigate the risk, how remote pilotage then it will provide it on a specific fairway. Now we have only the demonstration in one specific fairway. And then of course, this should be kind of like it should be escalated to start to test and to have the similar demos and similar exercises on different fairways. Of course, it may be, that's something that we have not yet discussed, but it may be where some cases or some scenarios, this is not a solution. This is not potentially applicable, but this is something still to be determined. So we are trying to test that, but this is something that is quite important to remark that. And I don't claim this only for remote pilotage. I basically mention it to everything related to autonomous technologies or smart shipping services, that everything will be ruled by the context. And what it means remote pilotage for Finland, if, for example, Canada wants to do the same, it may be something totally different. So that's something that I think that discussion and exchange of experience will be very fruitful in the future for this for the future development of remote pilotage. Yeah.
But do you see that I guess the approach would be relevant to other areas, but the considerations and factors coming from different states?
Yes.
It differently.
Yeah, of course, yes, because for example, the basis for elaborating the analysis will take consideration of these critical elements on the context that we are analyzing for that. This is the basis can be utilized, but then what I mean on the changes will be that the result may indicate something, may indicate a totally different way or totally different options to control the risk. So, but yeah, it is quite, the whole process that we utilize, it's kind of like something that can be applied, and most likely having, as I say, slightly different results on when applied to different contexts. But yes.
Nigel Greenwood has a question about tolerances. The concept of remote pilotage as a dynamic control problem raises the issue of tolerances. How precisely must the system respond in different conditions of traffic or navigational constraints? Does your model include factors addressing density of traffic or narrowness of the fairways?
We have these companies related to this remote pilotage on this definition of the safety margins, and that's something that we are working with them. We create this kind of like a very kind of like a short model where basically it represents a specific ship characteristics entering on a specific fairway and determining where the margins are basically fulfilled. And what it means about fulfill, it basically means that the remote pilotage service could be provided. And if the margins are somehow not fulfilled or violated, how you want to see it, then you need to analyze what is the option there. Most likely, then something else will be required, and the service may not be may not be provided with the conditions represented on this exercise that we have in the model. So that's something that we are trying to elaborate. We are trying to put more context on the execution of the model. Now we have everything on the geographical characteristics of the fairways. We are looking also into aspects related to elements below the water, also to understand these issues, and then try to more accurately determine all these kind of like a safety margins. But it's work in progress, and it's quite challenging, especially now because we also started to talk about how everything changed when we have ice. So then the navigation and the operation of those fairways entirely changed when we have ice conditions. So we are trying to look into how this can be basically elaborated or executed in the two seasons, so open water season and then navigation in ice conditions. Yeah, it's complicated, but yeah, it's progressing forward. Yeah.
Just a last question to wrap up. I want to go back to the start of your presentation where you raised that one of the main risks to pilots themselves is the physical risk of transferring to and from a vessel. And there have been a number of injuries and deaths associated with that transfer. Based on that, how did you find that the pilots reacted to the idea of remote pilotage and the demonstration project that you did to demonstrate pilotage as a remote operation?
Yeah, that's a question I get almost all the time when I'm presenting this, either by curiosity on the facts of reducing the risk, or also by the acceptability of the pilots knowing that remote pilotage is coming. And I say that basically in Finland, the pilots have been very positive and basically had been always on board this analysis, on board of the development of this work, because I think they also realize that the remote pilotage brings kind of like a new opportunities for them. So it makes some kind of like a potential positive changes for the execution of the work. And I think at least from the perspective that we have and then the involvement of the pilots here in Finland, everything has been quite well received by the pilots here on all the local cluster of pilots related here in Finland. This is something I discussed, for example, with colleagues in Greece, where they say that this kind of talks cannot be done, or these kind of ideas can have a very negative reception there. But I think here is the pilot looks more of an opportunity for further developing their profiles and enhancing the way that the service is provided and the opportunities they will have also for having a safer working place. Yeah. And then, of course, they are the ones who are commonly demanding, especially to technology providers, what are the aspects needed. If we want to do it, we're going to do it right. And everything what is needed has to be assured. We have been discussing about how to ensure the communication all the times, lack on representing of the images and communication and all the kind of critical aspects. They are always kind of like remarking what are the critical elements that needs to be ensured if we want to be doing this remote pilotage in the future. So it's a very, very productive and very nice experience working with them. So we are very, very happy on this case. At least in Finland, this is going quite well.
Excellent. Well, you can trust a pilot to have a safety first mentality, for sure.
Yes.
Yeah. I think that's the end of our time today. So thank you very much, Osiris, for sharing your knowledge. And thanks to everyone participating today for your questions and taking part. As I mentioned before, the recording and slides will be posted on our webpage, and I'll send out the links to everybody who registered. And please register for the next presentation. It will be Nigel Greenwood presenting on the research recently done with Claire Seas on the technology implications of technology implications for marine pilotage. And I've just put the link into the chat if anybody would like to register and hasn't done that yet. That will be Monday, June 10th at 10 a.m. Pacific. And I hope to see everyone there. Thanks so much for joining us today and have a great rest of your day.
Thank you very much. And I will send you these slides later today or tomorrow.
Thanks so much, Osiris.
Thank you.
Thank you very much for the audience. Have a nice rest of the day.